you are going to see that there is x. X is a variable. In the next expression, 5y, y is your variable. Then we have 3t plus 11, and that t is your variable. And in the final one, 16 over k, k is your variable. So most often we use a letter to be our variable and represent that unknown numerical value, but it wouldn't have to be a letter. In algebra, we have both expressions and equations, and it's going to be very important that you know the difference between the two. An expression is a mathematical statement that has no equal sign. So on your screen, you are going to see that you have two expressions present right now. You have 3k plus 9 and x squared plus 4x minus 5. Those are both expressions because they do not have an equal sign. And then we have an equation. If you have an equation, it will always have an equal sign. You will never experience an equation that does not. So here you have two examples of mathematical equations. The words that you see on this screen right now are going to be very important for you to know because we are going to look at taking sentences that are written in English and translating them over into mathematical expressions and equations. This is going to be something that you do throughout the year, especially when you're working with word problems. So these words are vital that you know. I have them grouped for you on the screen. The blue words at the top tell you what operation is indicated by the green words that are below them. There are a couple, though, that I want to bring your attention to here on the screen. So the first one that I want you to see is the one that says less than. So less than is one that we're going to want to mark here because when you're dealing with less than, it's going to be a special one. When you have less than, you need to switch the order of the two things that you are subtracting. And we'll look at an example of that here in a couple of minutes. The other one that I want you to look at here is the one down here that says twice. Twice is under multiplication. And while it does indicate multiplication, twice is significant because it specifically references multiplying by 2. So that is something that's important for you to know as well. So you can write down these words and continue to reference back to them as we move through the rest of the notes. So if we look at translating 7 more than k, we know that 7 is a number. And more than on the other page fell into the adding category. So when we write this down, we are going to have 7 plus k. So that is going to be 7 more than k. On the next one, you have the difference of 22 and W. So on the last screen, we saw that difference meant that we were subtracting. So we would have 22 minus W. On question number 3, you see the word product. On your prior screen, we find the word product here under multiplication. So when we have the product of 1/2 and m, that means that we are multiplying 1/2 and m together. Which multiplication you can write a few different ways. So we can write 1/2 and then your typical x for multiplication, so times m. That would be one option. But also when you're multiplying, you can just squeeze the two things that you're multiplying together. So if you just write 1/2 and then m next to it, that also means the same as 1/2 times m, or the product of 1/2 and m. On question number 4, you see the word quotient. So if we go back to this page, we can see that the word quotient was under division, so we are going to be dividing there. And it says the quotient of t and 3.5. So you can write this as a division problem. So t divided by 3.5 would be one of the ways that you could write this. However, a lot of times in algebra, we are going to see division indicated by a fraction bar. So you could also write this as t over 3.5, and that would mean the same thing. And then your last one on this screen, number 5, says 9 less than x. So on the previous screen, less than was the one that I had you mark, and I told you that we were marking that because while it means subtraction, we need to switch the order here. So what comes after the phrase less than is going to go before the subtraction sign. So in this case, we have 9 less than x, which means we're going to need to write it with x coming first. Less than means subtract, and then the 9 is going to come last. Moving on to your next set of examples. This one has the phrase a number written in it. When you see that, that's indicating that you need to use a variable. You can use any variable that you would like. I am going to stick with x because I think that that's one of them that you are most comfortable with. So we have 2 times a number. So if we're going to use x as our number, we know that times means to multiply. So we can just write that as 2x plus, we know that plus means to add, plus 15. So this would be the expression that represents what was written there. On number 7, you're going to see 7 less than. So that's important. We're going to mark that because that means subtract, but that's that word again, or that phrase that we marked back here that means that we need to reverse what we're subtracting. So 7 less than. So this part after less than is what's going to come first. The quotient of 9 and a number. So quotient was under division. So quotient means that we are going to divide. And we have 9 and a number. So again, we're seeing that phrase that means we need to use a variable. So again, here I'm going to use x to represent my number. So I'm dividing 9 and x. So 9 divided by x. So that's the quotient of 9 and a number. Less than meant subtract. So we have minus and 7. Question number 8 says the total cost is 12 times the number of CDs bought. So in this case, the first thing to notice here is that we have this word is, which I turned a different color for you. And if we go back to our list of words, is was the word that indicated equals. So for the first time in our notes, we are going to have an equation that we are dealing with here. So this is going to be an equation, and we're going to need an equal sign. So if I start at the beginning, I have the total cost. So total cost is something that I don't know at this point, but if I did know it, it would be a number. So I'm going to be able to use a variable there. So maybe we use T to represent total cost. So T is equals 12 times the number, so times means to multiply, the number of CDs bought. So it tells us the number of CDs bought would be a number, but we don't currently know how many CDs were bought. So maybe we just use C to represent the number of CDs. So then the total cost is 12 times the number of CDs bought. So this would be the equation that represents this situation.